at a quick video on ground and excited state in relation to the Bohr model. Okay, so remember that these guys right here are energy levels proposed by Bohr. Now this is our exaggerated nucleus right here, because the nucleus is very, very, very small in comparison to the rest of the atom. But it's just large right here because, you know, for emphasis purposes, okay? No problem. So what are we looking at? We are looking at the ground, okay, and the excited state, okay, in relation to whose model? In relation to the Bohr model. So B-O-H-R, B-O-H-R, the Bohr model of the atom. Okay, so what we're gonna do, we're gonna look at lithium again, okay? So I like lithium for some reason. Okay, nice and simple. So lithium, in terms of identity, right, is atomic number, okay, of 3. And could you remember what atomic number tells us in terms of particles? It tells us that we have 3 protons, okay, extremely important. We did that in the counting subatomic particles video, right? So we got 3 protons for lithium. Okay, now if lithium's neutral, right, okay, what's gonna happen? We agreed, let's recap again, that atomic number is the same as the number of protons, right? Atomic number tells you the protons. Now, if you're neutral, okay, your number of protons, okay, will equal to the number of electrons. B minus, okay? So protons are equal to the electrons when you're neutral. So we need 3 electrons. So my question to you is this. Can I put the 3 electrons in this first energy level, all right? Now you look on your reference table, right? You're gonna see the electron configuration for lithium, right? The electron configuration, okay, config for short, given as 2-1. And there's a reason for that. Because there's something called the 2n squared rule, guys, okay, that we talked about, all right? You have the 2n squared rule, and what does it tell you? It tells you the electron capacity, all right? Electron capacity or the energy levels. Now, here's the deal, guys. If your energy, okay, energy level, all right, number 1, you plug in the 1 where the n is, right? So you're gonna get 2 to the 1 squared, all right? So 1 squared is 1, and 2 times 1 is 2, right? So what's that telling you? That 2 right there is telling you that the energy level number 1 can only hold a max of 2 electrons, okay? So you can't violate that. So lithium having 3 electrons can put 2 in the first shell. I'll put 1 up there and 1 here, okay? But the other 1 cannot stay there. It has to go into the second energy level. Hence, that's why we have 2-1. In the first energy level, EL for short, there's 2 electrons in the first energy level, and in the second energy level, EL, that's EL1, that's EL2. In the second energy level, we have 1 electron. So over here, 2 electrons in the first and 1 in the second. So that's what 2-1s mean, okay, no problem. Now, we also did in class, right, demonstration, the flame test, and we said, right, that electrons can get excited, okay, or promoted to higher energy levels. So that's the excited state. Now the thing is, we want to be able to recognize that in terms of configurations, right? So here's the deal. We have lithium again, right? Normally, okay, 2 holes in the first, and the extra electron that he has goes there. But what happens, folks, let's say you zap one of these electrons here with electricity, okay? One of these guys right here. And it gets excited, it absorbs the energy, right? And we agree that's gonna jump to a higher energy level. So it jumps to a higher energy level. Now what do we have now? We have 1 electron, okay, in the first energy level, and now we have 2 electrons, 1, 2, in the second. So the configuration, instead of being 2-1 in the ground state, okay, it becomes 1-2. Now you ask yourself, is that a possible electron configuration? Yes, it is. But you have to be able to know, right, that it's in the excited state. All righty? Okay, so ground state, normal filling, excited state, right? How do you recognize it? You recognize it when you have a lower energy level that's not filled, but you have electrons in a higher one, okay? All right, we'll do one more example in a second.